Okay, I made this a separate video to part A of this question because it is essentially a completely different question. They both just claim to be talking about sweets. So there's orange and lemon sweets, and indeed each cost different amounts. It then gives us 3 pieces of information to come up with 3 inequalities. Although one of them is done for you, we need to find the other 2 before going on to do some solving with that and the inequalities. So let's look at each one. The cost of a bag of sweets is less than 24 cents. So you can see here that is what this is representing. 2x is how much it costs to buy x sweets. So there are 5 x sweets and they're 5 orange sweets. That would be 10 pence on them. And 2y, so that would be 2 lemon sweets, 6 pence on them. 10, 6, that would be 16. So that finds us the total cost in terms of the sweets. So let's look at the next one. There are at least 9 sweets in each bag. Now it doesn't tell us if it's talking about sweets that are orange or sweets that are lemon. It means both of them. So if I add both of them together, there's got to be at least 9. So that means it's got to be bigger than 9. It could also be 9. At least means it's got to be bigger than or the same as 9. So that gives us one of our other inequalities. Looking at this final line now, there are at least 2 lemon sweets in each bag. At least 2 lemon sweets, so that's just y. So I get some information about y. Y could be 2, or it could be anything bigger than 2 as well. Okay, moving on to using this to try and solve some problems. Well, first off, we're actually just going to have to do some graph plotting. It's asking us to shade, by shading the unwanted region, show the region which satisfies all 3 inequalities. So I'm going to start with the easiest. I'm going to start with y has to be greater than or equal to 2. So to do that, I'm going to draw the line of y equals 2. I'll just pause that and do that now. So there's the line of y equals 2. Now it can be on that line or anywhere above it. I've been asked to shade the unwanted region, so all the stuff below that line, I don't want any of that. That's not perfect, but it'll do the job. So anywhere in that red bit, bad news, we don't want to see it. So we're left with loads of different possibilities above here now. So let's rearrange it now by, narrow it down now by looking a bit more at some of these other inequalities. So we'll use this one now. So I want to plot the line of x plus y equals 9, and then shade the correct side of it. So actually, I find it a lot easier in my head, you might as well, to think about this in the form y equals mx plus c. So I've got y equals 9 minus x, so it's got a gradient of -1, and across the y-axis is 9. So I'll just draw that line now. So there we go, that's the next line. And part of that we don't want as well. We are allowed to be on the line and anywhere above it. Anywhere where x plus 9 is greater than 9, anywhere above it. So we don't want any of this stuff down here. Some of this stuff we sort of double don't want. Right, so that leaves still an infinite number of possibilities. There is no upper bound to the amount of sweets with what we've done so far. However, our final rule will provide that. This will be the final rule that puts a limit on it, and because we have a maximum, 2x plus 3y has to be less than 24. The cost of each pack of sweets has to be less than 24. So I just need to plot this line. Plot the line 2x plus 3y is equal to 24. So you can do that with a table of values or rearrange it to get y equals x minus 2/3 x, which is probably what I do. It gives you the gradient then as well. So I'm just going to plot that line. Okay, and there we go. Now I've done my best to demonstrate that this is a dotted line. It has to be a dotted line. You will lose marks if it is not, because the dotted line is means that we cannot have values on there. It is less than. It needs to be less than 24, the total price. If it's on that line, then that means the price is 24, and it should be less than. So I've done my best in this poor software to do that. It's not quite gone right either. This should be meeting here at 9.2 and going through at 12, so it hasn't quite, but hopefully you get the gist. The final thing we've got to do is shade in the areas we do not like. We want everything to be less than 24 pence, so we cannot have anything up here, anything on or above that dotted line is bad. So all of the rest of this gets shaded in, leaving us a very small white patch in the middle, and anywhere in there is where the region in which all three of those inequalities are satisfied. So these three, the bag of sweets costs less than 24 cents. There's at least 9 sweets in the bag, and there are at least 2 lemon sweets in each bag. Anything which is in that white area there, but not on the dotted line, will meet those criteria. So now let's apply that to solve a problem. So find the lowest cost of a bag of sweets, right, and the value of x and the value of y. That give this cost. Now if you look earlier, the more expensive are the lemon sweets. They cost 3, and the lemon sweets are y. So we want to minimise the number of y sweets in there, which means it's going to be somewhere low down. And if we try out a few of these points, you quickly find that the lowest one is this point here. Let's make that a bit bigger. Oh, what an ugly green blob. There is that point there. Now that point there has 7 sweets, 7 orange sweets, and 2 of the lemon sweets. The higher up we go, we still have 9 sweets all the way along this line, but it's just getting more and more yellow, so it's more and more lemon, so it's getting more expensive. And as we move right, we're just having more sweets, and that's obviously going to be more expensive. So that green dot is the cheapest place, and it has in it 7 x, so 7 orange sweets, 2 white, 2 lemon sweets. If we just do a little bit of working with that, 2 cents for each of those 7 orange sweets, and 3 cents for each of those 2 lemon sweets. So that's 14 plus 6, that's 20 cents it's going to cost us in total. Okay, and there you go, some linear programming for you with some common sense conclusions at the end.